Hi, last video we show you how to plot a continuous time signal in MATLAB. This time we're going to show how to plot a discrete time signal as shown here in this example. X of n has all three intervals, so let's go. Well, that's the MATLAB file. You open the file, and as we said before, you got to save it. I already saved it, but let me show you how you do that. Save it as, I just call it plot DTS1, so I know how to get it easily. All right, and I have to write this statement: close all, clear all, CLC, CLF, so I can clear the memory from any calculation and also clear the figures. So I start from scratch, and everything will be clear and clean and not affected by previous calculation. Now let's just look for the first interval n less than 0, but we want to start from -3. So the first interval will be n start from -3 up to 0. So let's go and define the first interval, and this time we're going to call it n1, not t, and should be integer. Start from -3, and this time you don't use 0.01 because you are going to have discrete signal, and it's just increasing by 1 each time: -3, -2, -1 to 0. So the increment is equal to 1 up to 0, semicolon. Now I want to know I want to write its value, which is x1 should be equal -1, but as we said last time, you write ones, and the size of ones should be the same size of n1. So let's find the size, called S1. It's the size of n1. And we write here ones S1, the size of n1. What does it mean? Let's just run the program to show you what does it mean. Just let's put the semicolon here. It's very important to understand every step. So n1 from -3 up to 0, increasing by 1. So what is the size? Let's just print n1. If you want to print n1, that's what you get: -3, -2, -1, and 0. So what is the size, or how many columns you have? You have 1, 2, 3, 4. So you got 4 columns but 1 row. So if you want to find the size, which is S1, that's what I write here: S1, the size of this one. You see, that's 1 row, 4 columns that we did. Okay, the same thing should be for x1. So if you now type x1, you find you still have the same. You see, ones, you got 4, 1, 2, 3, 4, 4 ones. So the number of ones is equal to the size s1. That's great. All right, but somebody's going to say again that is not equal to 1, -1. Just, it's easy, multiply this whole thing by -1. So that's -1 times 1. That will make it -1, -1, -1 4 times. Okay. You just check. Let me write down x1. Here you go. You got the -1 4 times, exactly corresponding to the size of n1. Now I'll move to the second interval, n2, and just I don't remember the interval. n2, this is the interval n2, that's from 0 to 2. All right. So it's from 0, and increment is equal 1 because discrete, up to 2. And what is the value of x at this interval? 3n minus 1. I'll just type it. 3 times n, not any n, n2 minus 1. So you got, again, I'm not using here the size. Why? Because every time you calculate n2, for every value of n2, you have it here, multiplied by 3. Excellent. All right. So now I go for the last interval, n3. And it's from 2 up to, let me just, oh, that's not right. From 2, increment is 1, up to, okay, they said that it should end at 4, so that will be from 2 up to 4. The increment is 1. Again, we get the size, call it S3, to distinguish between this S and this S. S3, that's the size of N3 and x3, the value of x3 according to the question 5. So we'll do the same thing as we did here, ones and then multiply by 5. So we'll say 5 times ones, and the size of this vector is S3. All right. So we have all set here. I collect N1, N2, N3 in one vector. I call it N. And I have N1, N2, N3. All right. The corresponding value for N will be X. And you should write in order X1, X2, X3. So you have vector, two vectors, the vector of N. And if you wish to look at them, all right, let me just, that's N. All right. So you got the first 4 for N1, you got N2, and then you got N3. And if you calculate it, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you print X should be 10 also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 the same. So you are fine. Now you go to make the plot. But remember, it's discrete. You do not use plot. Use stem with the discrete. And the same thing. The independent variable is N. Then the dependent variable is X. And if you use grid, let's just now check. And here you go. Right. That's okay. It's it. All right. We'll do the same trick. We needed to make it clear. So we'll just go and add here the width of the line. And it'll be line width 2. And let's put limit on the y. Start y from, let me check. It starts from -1 up to 5, so we can see from -2 to 6, so we can see. So that y limit will be from -2 up to 6, so that will be clear. All right, and you want x label. X label, that will be, call it n, and y label, call it x of n. Don't forget to make it square bracket, discrete. And let's check if we have any error. Run the program. Oh yes, error in line 22. Yes, x label. Oh, it should be L. All right, that was simple. Let's just check again. All right, everything is fine. So just let's look at the result. Okay, here you go. You got it right. That's n, xn. And remember to make copy. Make copy figure. And you go here. Paste. Don't ever take screenshot. Just do it like that. All right. All done. Bye.